Bring her up. Okay, bring it.
Nice. I actually see a lot of layers in this core as well. We have a silty, sandy mix in the surface, 5 centimeters, 10 centimeters, with gas pockets in. Then we had a coarse sand layer that you see right through here with darker material in it, much darker than the coarse sand we saw earlier. So we see actually a lot of coarse sand particles in here. And then that overlying silt and clay again with a few gas pockets. Then down to another layer of coarse sand. And here at the very bottom we see silt and clay that's actually lighter in color than anything we've seen in any of the other cores, which could indicate different mineralogy again. So overall, an interesting core with 3 distinct silt clay layers separated by layers of coarse sand. Well, after we photograph the core, we bring the core here to the Sedflume itself. And here we see a core mounted into the Sedflume. And the core inserts into a collar right up here that mates it to the flow channel itself. What we do is we recirculate water from a 500-gallon tank using this swimming pool pump right here and drive the flow up into the flow channel here and down over the core itself. With this, we can control the flow that's coming over the core itself so that we know the flow rate and shear stress that's being exerted on the surface of the sediments. What we do is we start at the surface of the core and run through a series of shear stresses, increasing shear stresses by increasing the flow rate, and measure the erosion rate of the core at each of the shear stresses. We do this by keeping the surface of the sediment level with the bottom of the flume channel here. As the sediments erode down into the core, we use a hydraulic jack here to push the sediments up with this piston to keep them level with the bottom of the flow channel. So we know how much we've eroded here by measuring the distance the piston's moved up and the time that it's moved up over, and we get an erosion rate, or erosion velocity in centimeters per second. We also open up the top of the flume between the different flow cycles and take measurements of bulk density and particle size so that with the bulk density of the sediments and the erosion velocity, we can actually quantify the mass of sediments that's coming off at any given shear stress. So using this, we go down the core and erode the entire core and get data points all the way through at different shear stresses and different erosion rates. And what that allows us to do is construct a picture of the stability of the core quantitatively. And what that allows other researchers to do is to take that data out into the lake itself and help to quantify how much erosion any area may experience due to the natural forces in that area. Natural forces being currents or waves, or also anthropogenic forces such as boat wakes and other processes going on out there. And you can see active erosion starting to happen, and some scour pits there towards the front of the core. What we're going to do right now is, now that it's eroded, we're going to bump the core up just a little bit. See the core move up slightly, just to keep up with the amount of erosion, overall erosion going on. Also, you can see worm tubes that are embedded in this top centimeter or so of sediment. Those worms are probably less than a half a millimeter in diameter. And, oh, there goes some nice clumps of erosion right there. Oh, pulling right off. So as we exposed a little more sediment, it made a little more sediment available for erosion. And it's really peeling off just the top oxidized layer of sediments and flocculated clumps. So that's pulling out with all the worm tubes and all the biofilm material that they're excreting and other organisms are excreting, and kind of, but roughly as we double the shear stress, we expect an order of magnitude more erosion. So we had anywhere from 4 to 5 millimeters in the last period. This period, just according to sediment theory, we would expect 4 to 5 centimeters in the same period of time. So we've just finished our first shear stress cycle on the core and eroded about 5 centimeters of sediment. So now we want to get in and get some samples of the material that's below the surface layer of the sediments. So what we do is open up this door on the top of the Sedflume, and we actually get in and directly sample the surface of the sediments. Okay, so here we're taking a bulk density sample, and the idea is we've drained the water from the surface of the core and we're sampling them. Careful not to capture any extra water into this. And we've collected a large sediment sample into a pan that we'll now do a wet and dry weight test on. Additionally, we'll collect another sample for particle size distribution. So here we're going to take off an area that's higher than the rest of the sediments due to uneven erosion of the sediments. And we'll bag those into a whirl pack for analysis on a laser diffraction particle sizer. So here the bag is denoted with the core name and the sample number. This is the second sample we've taken from this core. The first sample was at the surface, and now we're 5 centimeters into the core.